Good morning. So we're going to continue working on this the playing card example. On Monday, we looked at a class that represents a single card, and then today we're going to look at a class that represents a collection of cards, which is the deck, which is all the cards. Then we're going to also look at another class that represents a collection of cards, which is a hand, which is a smaller number of cards for a particular game. The reason we're doing this example is that if you have started Lab 11 or look at Lab 11, there's this kind of the analogy where you have a class that represents a single photo in the same way that we have a class that represents a single card. And then we have a class that represents the collection of photos, which is the album, in the same way that we have, for instance, the deck. Let's 13. If there's anything new, but anyway. Okay. So for this class meeting, for the first part, when we talk about the deck class, I'll be doing most of the talking and walking you through this. Most of the code is already written. This deck class, and then we'll see another class where you'll be. So a deck of cards, like the pile, oversized novelty playing cards here. The deck represents all of the cards, rather than a single card. And on line 5, because we're going to be using the card class, which is defined in card.py, this file is deck.py, then we do need line 5 to tell Python, like, when I say capital C card, I want you to read that from the file card.py. You'll need to do this in Lab 11 too. Also, things we've seen before, like there is this random library. Somebody wrote some code that has these functions, and one of them is shuffle, which reorders elements of a list, and that's used. So we have the class that represents the deck of cards. On line 11, we have the constructor, and we've seen like all these constructors before that take some parameters and then initialize some instance variables. This one does not do that, but rather it calls this method reset deck, which is going to recreate the deck of cards, which we'll look at it in a second. So a couple of things here. The constructor is the method that's called when the object is created, but it doesn't have to take parameters. It doesn't have to initialize instance variables. It has to exist, I guess. And it can call other methods. But when you call another method in the same class, we saw this the other day, where I still say self for this object dot reset. It's reset deck. The reset deck method, which is down here, as you can see on line 26, resets the deck with all 52 possible cards. So these are the 13 ranks of the cards, like the number, and these are the 4 suits. 13 times 4 is 52, and it's just a double for loop. So for each suit, get rid of all the ranks, and then on line 33, it's creating a card using each rank and suit as it changes, so all possible combinations. It's creating a card and appending it to the list of cards, which was initialized on line 20. So another thing to point out, like on line 28, is it's initializing the list of cards. We've seen that sort of thing happen in the constructor. It doesn't have to happen in the constructor. It can happen in any method where we're creating an instance variable, in this case, initializing it to an empty list, and then appending each card. And we talked on Monday about, like, even though this card being created doesn't have a name, like there's no variable referring to it, we can still access it within the list, self.cards, and that those objects are all what functions do you have creating the deck of cards. Oh, right, sorry.
But the object in the list has a name.
Yeah, if the object in the list does or does not have a name, how would that change the stack diagram? So, any excuse to draw a stack diagram, I will take you up on that. So, you have the stack, the heap, or the values, and let's say, like C equals card soup, and then self.cards.append C. So the short answer to your question is, if you look at what's on the board versus what's on the screen, they do the same thing, assuming line 33 is replaced with these two lines. They do the same thing. The only difference is that now there's a variable called C, whereas before there wasn't. So the stack diagram, right? So the stack diagram for this function, which is reset def. So the parameters, so let's see, there's self, which refers to the deck object. There is ranks, which refers to the list of ranks. There's suits, that refers to the list of suits. And then there's C. So when I get to this line here, I say C equals card rank suit, then that's going to create this object that has, some rank, whatever that is, and some suit, whatever that is. Then when I say self.cards.append, so there's the list of cards. So self.cards.append, it's going to create another box. Remember, we never have anything in the box other than arrows pointing to things. And this would point to here, because we're saying self.cards.append C and here. So then what happens the next time we call this, because it's in a loop? So I'll use a different color. Maybe. So then what happens the next time we do this code in a loop? It says C equals card, whatever rank suit are now. It doesn't change here, it changes like where C points. So this would be rank suit, whatever they are. And then when I say self.cards.append C, that's going to do this like that. So even though like the variable C no longer refers to that first object, that first object is still there. It's the this red box in the list. But now when I say C equals card rank suit, it doesn't change this object here, it changes what C points to, which it always does. But if I change the variable, it changes what it points to, and then I append that. If I didn't have C, and then what's on the board on the screen on line 33, where it would just say card rank suit, it would create the object but not have a variable pointing to it from the stack. It would just kind of be there with like an anonymous sort of thing, and then when we append it, we'd still have the arrow pointing to it, but it wouldn't have anything coming from the stack. I forgot to bring my phone. Anybody up front, can you take a picture of that, just in case anybody asks for it? Logan, if you could send that to me, thank you. Other people can take a picture of it too, but I just want to make sure I have it. What other questions do you have about this example? Other methods that we've seen, the string method is just printing that thing as a string. Important to note, the string method on line 15 doesn't print anything. It returns a string. It doesn't print a string. On line 22 is something we've not seen before. So we've seen underscore underscore init. We've seen underscore underscore string or str. But this is a new thing for us. If we have an object, like we say, you know, in a couple minutes, you're going to write a line of code like d equals deck, blah, blah, blah. And then I want to say length of d. Well, we've seen like length of a string, length of a list, probably it. But it turns out you can get the length of any object if you've implemented the underscore underscore len underscore underscore method and have it return an int. I don't know that it makes sense to talk about the length of an employee. Like we saw an employee class the other day, last week. Like, what does the length of an employee mean? Or the length of a card, even. But I suppose the length of a deck, like, if I want to know how many cards are in the deck, this is kind of a shorthand of knowing that. So in the same way that if I say print d, right, recall, and we're going to do an example of this in a minute, this calls d dot underscore underscore str underscore, like that. If I say length of d, that calls d dot underscore underscore len. So the length function knows to call the length function I've written here on the left in black knows to call the underscore underscore len underscore underscore method on the object. So it's kind of a shortcut for that. There is on line 35 this shuffle function, which allows us to shuffle the deck or reorganize the cards. On line 37, seems like it's recursion. It's not recursion. Like, yes, functions have the same name, but this shuffle is the one we're importing from the random library. And whether you have a list of cards or strings or whatever, this will reorganize, reorder them. And then, go ahead, Alex.
Why can you use that variable name?
Yeah, why can you use the name, the variable name, or the function twice? I guess on line 37, my guess is that on line 37, it realizes that if I was calling shuffle, if I wanted to call shuffle on this object, it would have to be self.shuffle. But it knows that when I say shuffle just like that, it's a function, not a method. It's not being called on an object, so it must be some other shuffle function. Then I think it would look in this file to see if there's a shuffle function. There's not, so then it would look to see, like, did I import anything? And there is. So I think that's the reason. The last thing, and then I'll have you write a little bit of code, is this deal method. So when you deal a card, the self.cards is the list of cards, and then this function, pop. So pop is a method defined on a list that returns and removes, in this case, the first card from the list. So let me make a note of that. So pop, in this case 0, removes and returns the first element of the list. You can imagine if this is my deck of cards and I deal a card, right? I want to give you, whoever, that card and take it out of the list. So pop means I remove this card from the list of cards, and then I return it, so that now this is no longer in the deck. This case is no longer in the deck. Why is it called pop? It's a long story that you'll learn in 35, I suppose. And then 0 means kind of like the first, it's the first element. I guess if you had like, I don't know for sure, but I think if you said pop 1, it would 2 cards, something like that. But anyway, for us, suffice it to say, this is how we remove an element and return it. So I guess I'll walk you through this part here because it's, well, half of it is on the board already, but there is one part that I'll have you write. So here we're going to test our deck class. We're going to create a new deck. So I can just say D equals deck. In the other examples we've had, the constructor took an argument, maybe like the name of the employee, or when we created cards, the rank and suit. But here, the constructor doesn't take any arguments. And this will call, remember that the constructor calls the reset deck. So I don't have to do that myself. Because if you look at the constructor, it doesn't actually, on its own, create the cards. It calls reset deck, which creates the cards. Then to print the contents of the deck, right, what I'm just kind of getting at is just print the object D. This calls D dot str. Whoops, that's wrong. Sorry. So, that's on board. Also, something example on line 53, printing the length of the deck. We have not seen this example before, except that I just wrote it on the board a couple of minutes ago. But if I want to know the length of the deck, I can say len d. That doesn't print it, right? So I'll say print len d. Next, shuffling the deck. Well, there's a method called shuffle, and the point here is like, do you remember how to call a method on an object? It's the name of the object dot the name of the method, and then shuffle doesn't. The shuffle method doesn't take any arguments to take any input. I guess here, where it's printing the contents of the shuffled deck, the point is that if you print it again, that you'll see that the cards got shuffled. But this is the part I would like you to do. In a loop, deal a card and print it out 5 times. So when I first read that, I'm like, why am I going to print it 5 times? I think what it means is deal a card and print it out 5 times. So let's say deal and print out 5 cards. So this is the part I would like you to do. You should not change the deal class. So you should not change the deck class. You should not change the card class. Should only be a couple lines of code. So to write a loop, deals 5 cards and then prints out. So I'll give you a minute to do that.
The lack of typing makes me think either everybody did it already while I wasn't paying attention, or we're not really sure how to do it. So anyway, we'll assume it's the first one. So if I want to do something 5 times, I can write a loop for instance, I and range 5. It's been a long time since we did anything like this. We're used to looping over lists. But recall, I guess like first I talked about loops. I will create a sequence 0, 1, 2, 3, 4, which contains 5 elements. I will take on each value. We're not actually going to use I in this, but this is how we can do it 5 times. Then remember the deal method removes and returns the first element of the list, which is a card. So I can say something like C equals D.deal. You can call this variable on the left side of the equal sign anything you want. I mean, it's a name, but I would not call it capital C card because that will definitely be capital C card is a class. And even though, like you know and I know, that deal returns a capital C card, we don't have to put that in its code. We just have the variable C, which is the card that gets dealt, and then the idea was like print it, so print C. This calls C dot string, which we saw last time prints out like 3 of clubs or whatever it would be. So the point of this example is like, oh my god, I don't remember how to something 5 times. That's line 63. And in line 64, we're calling the deal method on the deck. So it's the name of the deck variable, which is D dot the name of the method. Deal does not take any inputs, as we see on line 39. That returns a card, but this code doesn't have to include the word card. It doesn't have, we're not creating a card. We're not creating a new card. C is just a card that gets returned by that method. And then what's following this is just kind of demonstrate that those cards are no longer in the deck, and that the deck got smaller. And I'm going to skip this next part also. So what questions do you have about anything? Oh, yeah. Oh my gosh, I don't know how we made it this far into the class without accidentally including this. Okay, so on line 19, there's this plus equals, which I know some of you have already discovered. So plus equals is a shortcut. We have on numerous occasions seen something like sum equals sum plus x, right? When we're like adding up some numbers. Plus equals is a shortcut that is exactly equivalent to what's here, where I can say sum plus equals x. And the 2 lines of code on the board are exactly the same. It's just like this, the green one, the bottom one, is just a little bit shorter and looks cooler, maybe. So on line 19, what that means is that it's accumulator pattern. And it's just line 19 means result equals result plus blah, 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 blah. It's totally fine if you want to use this shortcut, like if you're doing accumulator pattern, you're like, where has this been for 11 weeks? But better late than never. But it is a shortcut for it. Yes. Yeah, so I'm going to erase what's on the board here to answer that second question. We have seen like print percent point, 2f, right? And And the point 2f means 2 places after decimal point. We've seen it numerous times. If I use a number, even if it's before the decimal point, or in this case, so for instance, it says %3s percent, whatever. This means use 3 spaces to display or print the string. So I'm gonna get this wrong. Here, let's do this on them for real, not do it wrong. Okay, so Python 3. So if I have like a variable value, which is we'll say like a, and I do print value, right? Just prints a. If I do print %3s value, which is what's on the board. So notice that it put 2 spaces in front of it because it's using 3 spaces total to print it. If I had said something like value equals xy, and then I do the same thing. So it's kind of like right justified. I know it's really hard to see all the way back, but it is, there's an empty space here, and then it's using however many more spaces it needs. So it's using 3 spaces total. And so it's just something so I can make it like kind of tabular, I suppose. And in this case, everything would be right justified. If I make it like %8s, I think that makes it a little easier to see. So there's 6 empty spaces here. And then this.
The total spaces.
Yes, the total spaces. So now I have %8s exclamation point. So it's 8 total spaces to represent value. And then in this case, follow that exclamation point. I don't know what happens if it's too many spaces. I think it will just like show. If I just do %1s, I think it's gonna just be like, yeah, I can't do value in 1 space, so I'm just going to use as much space as possible. This might have come up in some of the earlier labs where you were like printing a table of results or something. I don't know, maybe not. Yeah, maybe not. But anyway, it's yeah, just for like affecting the formatting of what gets printed out.
I'm confused with why.
Yeah.
That space.
Yeah, so let's run this code. Yeah, the question is like, why are we doing this? Like, why would? Oh, that's not what you want. Dummy. Let's see. No, this is a bad example. Yeah, this is, it kind of doesn't make sense to do it here. But I guess in the general case, if I did have like, yeah, we could do a quick little example here. So Python 3 names equals, oh, so hard not to say Bluey. Bluey, Snoopy, give me another dog name. Clifford, good one. That's enough. Then for name and names, print %10s. Okay, so what I'm going to do is that I'm going to iterate over the list and print each one. And I'm going to give it 10 spaces total. And that allows it to be like, let's lined up. So I guess that would be spaces if I want to print it. So now I know, if I were to saying like it's so that way it's lined up, like this part is lined up. Because if I had just done percent %s as a good doggo, they would all be kind of jagged on the right. So now, and you can imagine if I had a table of numbers or whatever, and I want to make sure they're like different columns and they're not all pushing each other off to the side, then I can use that padding. It doesn't have to figure out like, okay, well, blue is only 5 letters, so we need this much padding. Like it figures that out for us. I think the main takeaway, though, I don't know if this will come up again, but is just, yeah, just kind of like giving this padding this amount of space for it. It's good that you caught those things on line 19. I would not remember to bring them up. But what other questions or comments do you have? Oh, I was supposed to show this slide, but I forgot. But anyway, we already talked about the deck class. Okay, so I'll put it back. Okay, so the next class we're going to look at refers to the game Blackjack. And it occurred to me while I was walking to the train station this morning that we should not assume that everyone's familiar with the game Blackjack. So the very short version of the game, it kind of doesn't really matter for what we're going to code, but the short version of the game, taking the betting and this aside, Blackjack is a card game in which players have a hand, which is some number of cards that are randomly drawn, and the hand has a value. Each card has a value, as we talked about the other day. Like, for instance, this card has a value of 6, and yeah, like a face. Not that one. Face card, there was one here a minute ago. Face card like Jack, King has a value of 10. So, in this case, you know, like a 3, a 4, a King, that means I have 17. What makes it sort of complicated is that an ace can be a 1 or an 11. So, in this case, I either have 4 or 14 points. The goal of the game is to try to get a score higher than the opponent, which might be an individual, it might be many individuals, it might be like the place that's taking your money where you're gambling, the dealer, but regardless. But you can't go over 21. You go over 21, then that's too high. We're not going to implement the We're not going to implement the Blackjack game. I think most of the code is already provided to you. It's not really related to creating objects, which is what I want to focus on. But I do want to focus on a class that represents a hand. And so in this case, you know, here my hand consists of these 4 cards, and I want a class that represents the hand of 4 cards. Not the deck, which was all the cards, but rather the cards I happen to have in this game. So as we're going to see in a minute, the instance variables would be the cards that I happen to have, like the name of the player, for instance. There's getting the value of it. So in this case, well, that's that example. In this case, you know, as I said, the value would be 17. It does get a little bit complicated. It's because the value is either 5 or 15, because the base is 1 or 11. And then other things that we see. So let's start by looking at the Blackjack hand. Whoops. Oh, okay, so it's not blackjack.py. That's the game. And I don't think we're going to look at that. Definitely not today. Blackjack underscore hand. Which is on the screen right now. That's representing some small number of cards that has value. I think what I'm going to do is I think most of the methods are not. And then I'll give you a task to do as we wrap up today. So it says at the top to do import the card class. So it's probably not in the code here. Yeah, it's not here yet. But at some point we're going to do something with cards, or at least call methods on cards. So remember to use the card class. We need to import it. We need to tell Python, like, when I'm using capital C card, or when I say in my code capital C card, so getting that definition from card.py in the same directory. So now I have this class called blackjack hand. The name, I guess, is just the name of the person, player of the game. And on line 12, self.hands, I would prefer cards there, but whatever. The hands, that's going to be the list of cards. So let's put a comment here. This is the list of cards that the player has. And I'm going to blow through these methods if they're not. So we want to get the length of the hand. I guess that would be like return the number of cards in the hand. So that if we have a blackjack hand object, and then we call len, parentheses, the name of that object, that would call this method on line 16, and we want to return the number of cards in the hand. Well, the cards in the hand is self.hand, so we return len of self.hand. So a few things to unpack here, I guess. One is it's returning number. It has to return the length. Has to be an integer. And I want to get the length of that list, which presumably has the cards. I think there's a way for it to get cards. We'll come back to that. Presumably has the hand the cards. Hands, the list. But we can't just say return len parentheses hands, because there's no variable called hand. But there is a variable called self. It's the parameter. And self has an instance variable or property called hand because of line 12. So that's why it's this. Oh, it's by that card. The string function, remember, will return a string. I don't know what I want to print for the hand. I'm too lazy to print all the cards. Do this later. But anyway, that has to return a string. What's that? The number of points is the complicated. Well, that will be get value eventually. We'll come back to the string. Getting the name, this is just a accessor method that's going to return self.name, which was from line 11. I get them both on screen at the same time, kind of. So in line 11, we created an instance variable called name. That's this part here that I've highlighted on the left. And then here on line 24, I'm just going to return that. On line 26, we want to add a card to the list. Actually, I'm going to let you do that. So I want to add a card to the list. List. So parameter card, clearly being cards. So this should just be one line of code, which you're going to something. And again, this is partly why we use this as an example this week, because where we have like one class as a list of objects of another class. We actually did see something like this a couple minutes ago. We didn't type it, but when we saw the creating the deck of cards, and then when you start to do Lab 11, as I mentioned, you have a photo album, which is a collection of photos, and you're adding an individual photo to the album. So in this case, self.hand is the name of the list, and then we're going to append the card. Yeah, we were thinking kind of crazy. We could do self.hand equals self.hand plus list containing card. Might even be able to do plus equals list containing card. That would be really crazy. I think this would work, but I think append is a pretty good way to do it. So the interesting part about, or the interesting challenging part, is getting the value of. So in this case, the value of the hand is 17, right? Because that was 4 plus 3. In this case, right, the value of the hand, ace 4 3, is both 8 and 18, because ace can be 1 or it can be 11. Because the goal is to get as high as possible at 21, I would say the value of this hand is 18, 7 plus 11. But in this case, right, I would say the value of this hand, if it's 20, the ace is 11, then I'm over 21. So I want to count it as 1 in this case. So that would have 18. So calculating the value is not as straightforward as adding them up, because it depends on the ace and also how many aces you have. So if I have multiple aces, this is both 9 and 11 plus 1 plus 8 is 20. Whatever it is. So getting the value and getting the best value is kind of complicated, and we will save that for Friday. In the meantime, we'll do that Friday. On Friday, we have a quiz, the last quiz of the semester, Tears. And if you look at the study guide, which you really should, you will see that there are a bunch of questions on the study guide about, here's some code, is it linear, logarithmic, or quadratic? We haven't really done examples like that in class or in a lab, but very, very, very likely to be on the quiz, since it's in the study guide, with like 4 or 5 questions. So here I have this chart that I showed previously a couple weeks ago when we were talking about this, that kind of summarizes it. And I think when you're looking at the study guide, which you will between now and Friday morning to study, keep all of this stuff in mind. That linear complexity means if we double the size of the list, we have like twice as many comparisons. It doesn't mean we go through the list once. So for instance, if I have a list of 1, 2, 3, 5 things, and then I look at like all except for the last one. So I look at this one, this one, this one, this one. That's still linear. And it's like, well, but we didn't look at every element. It's not all n elements. We looked at n minus 1. Right? But if I double the size, we're doing around twice as, and we just don't look at the last one. But I'm doing around twice as many things. So linear doesn't mean it's exactly n, where n is the input size. It means it's around that, or if I double the input size, I do around twice as many things. Logarithmic means if I double the size of the list, we do one more comparison. And binary search was the example for that. It doesn't mean that we do exactly log of n comparisons or log of n operations, but it means that if I do, if I double the size, that I'm doing one more comparison or operation. An example of that would be, well, binary search, or anything where it's like I'm kind of cutting the thing in half, or every time through the loop, I'm only considering half of what's left. Those are tricky to identify, definitely, compared to the others. So that's what that means. And then quadratic, again, does not mean it's exactly n squared. In fact, neither of these is exactly n squared. But it does mean if I double the size of the list, I have to do 4 times as many operations. It's like I'm doing twice as many things twice as many times. The big hint I'll give on quadratic is if you see a loop within a loop, that's a pretty big hint that it's quadratic. So if I have, for instance, this, a single loop, that's a pretty big hint that it's linear. Depending on what I do with I, it could be logarithmic. For instance, if I'm like doubling I every time or something like that, because then I'm like cutting in half what I have to do. But if it's a single for loop, that doesn't mean it's always linear, but it's like a hint. Like think about what linear means, but this is kind of a hint. However, if I have a loop if I have a loop within a loop, that's a pretty big hint that it's quadratic. Because I'm doing, let's say now n and had twice as many things, I'm doing twice as many things twice as many times. If n is now 2, if n is doubled, I'm doing twice as many things because I'm doing this loop twice as many times. I'm doing twice as many things twice as many times. So that's a pretty big hint. Again, not going to say that that's always the way it's going to work out, but these are hints. And I would tell you that this is not like a hint that I'm just giving you for the quiz. This is a hint I give everybody when I teach this class. But again, look at the study guide, please. There are a lot of questions on there, especially stuff we haven't really talked about, that will definitely be on the quiz. What questions do you have about this? Lastly, quiz 5 retakes, last call. It would be today around 1 to 2:30. We are having a quiz Friday, and then the lab. The first part is due Sunday, and then the second part is due Friday, because that's the last day of classes. And that's it. All right, see you Friday.